Hello everyone, welcome to the certificate course on the reasoning and quantitative technique. In this video, we are going to discuss about the aptitude topic, permutation and combination. In quantitative aptitude, permutation and combination are crucial concepts as they provide the foundation for calculating the number of possible arrangements in our selections from a given set, where the key distinction lies in whether the order of selection matters, then it is permutation, or not, then it is combination, making them essential for solving problems related to probability, statistics, and various real world scenarios. So, first let us learn what is factorial notation. The factorial of n, this is n factorial, denoted by n factorial, is the product of number of all numbers less than or equal to n. So we have n, n minus 1, n minus 2, etc. up to 3, 2, 1. So if you have 2 factorial, then the product will be 2 into 1, that is 2. So 3 factorial, then the factorial is 3 into 2 into 1, is 6. So 0 factorial is 1, or 1 factorial is also 1, or if you have 4 factorial, so it will be 4 into 3 into 2 into 1. So that is equal to 24. So this is a factorial notation. And some problems if you want to solve in factorial, if you have n factorial, can be written as n into n minus 1 factorial. So if you want to simplify 10 factorial divided by 8 factorial, so you can write it as 10 into 9 into 8 factorial divided by 8 factorial. So this product will be equal to 90. Fundamental theorem of counting, principle of addition. If an event can happen in m way and another event can happen in n ways, then either of the events, so either first event or second event, can happen in m plus n ways. So this is fundamental theorem of addition. Principle of multiplication. If an event can happen in m ways and another event can happen in n ways, then both the events can happen in m into n ways. This is principal theorem of multiplication. Permutation. So it is the number of ways different objects can be arranged in a row. Here order is not important. So that means order is important. AB is not equal to BA objects. So permutation of n different objects taking r at a time is given by npr is equal to n factorial divided by n minus r factorial. Say for example, if you have 5 objects and if you want to arrange 3 objects at a time, so 5p3 will be 5 factorial divided by 5 minus 3, that is 2 factorial. So it will be 5 into 4 into 3 into 2 factorial divided by 2 factorial. So that is 5 4 so 20, 23 is 60 permutations. If you take permutation of n objects taking all at a time, so that is n factorial. So that is npn equal to n factorial. Say 6p6 equal to 6 factorial. Sometimes some objects or some elements or some alphabets will repeat in the given number or given uh, value. So here, how many times the value is repeated, that you have to divide. So that will be n factorial divided by p factorial. Say for example, if there are 7 objects in which 3 objects are of same time, then the permutation will be 7 factorial divided by 3 factorial. Next, the circular permutation. It is a number of ways n different objects can be arranged in circle is given by n minus 1 factorial. Say if there are 9 objects which have to be arranged in a circle, then the required permutation will be 9 minus 1 factorial, that is 8 factorial. Like it's mostly used when finding number of necklaces, a number of bracelet, or number of ways of arranging certain number of people around the table. So that is, we use circular permutation in that case. Okay, next we have combination. It is the number of ways in which a selection can be made from the given object. Here order is not important. So that means A, B and B A both are equal. Whether we choose first A or B next B, or whether we choose first B or next A, here both are considered as same. Combination of n objects taking n at r at a time is given by NCR is n factorial divided by n minus r factorial into r factorial. This is the formula for combination. Okay, question. How many words can be formed by using three letters of the word Delhi? So first let us find how many letters we have here. Okay, here we have in Delhi word n is equal to 5 and you have to take only 3 letters at a time. So required number of permutation equal to 5 3 3. So that will be 5 factorial divided by 5 minus 3, that is 2 factorial. So 5 into 4 into 3 into 2 factorial divided by 2 factorial. So total number of words is 60. So we can form 60 words. In how many different ways can the letters of the word 5 can be arranged? So here again we have n is equal to 5. Since we did not mention how many letters you have to take, we have to chase all the letters. So r is also 5. So here n p n equal to n factorial. So we have 5 p 5, which is 5 factorial, that is equal to 5 product of all the numbers less than or equal to 5. So the answer is 120. So 120 words, 120 ways of arrangements are possible. In how many ways letters of the word accountancy can be arranged? So first let us count how many words we have here. So here number of words n is equal to number of letters, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 words. Okay, in accountancy there are 11 words with, there are some repetition, like we have 2 A's, then we have 3 C's, and then we have 2 N's. Okay, these are the repeated letters in accountancy. Therefore, total number of words will be equal to 11 factorial divided by 2A, so therefore 2 factorial. We have 3C, therefore 3 factorial. Again we have a 2n, therefore 2 factorial. So this, if you multiply, we have 11 into 10, 9, 8, 7, 6, 5, 4, 3 factorial. We can simplify. 2 factorial is 2, 3 factorial and 2. So this 3 and this 3 we can cancel. And this 2 to the 4 we can cancel it 4. So we have to multiply the product of all the numbers starting with 11, 10, 9, 8, 7, 6 and 5. So product is 16 lakh 63,200. In how many ways can we select a team of 4 students from a given choice of 15? So since we have the word select in this question, so this is a problem of combination. So we have to find the combination, but there are number of possibilities 15. You have to select only 4 students at a time. Therefore, total number of selection is equal to 15C4. That is a 15 factorial divided by 4 factorial into 15 minus 4, that is 11 factorial. So we have 15 into 14 into 13 into 12 into 11 factorial. We have 4 factorial is 24 into 11 factorial. So this 11 factorial and 11 factorial cancels. So we have 15 into 14 into 13 into 12 divided by 24. So total possible selection is 1560 ways. So total number of teams which can be formed is 1560. How many words can be formed by using the letters from the word driver such that all the vowels are always together? So here we have in this word driver, we have two vowels I and B. Since we have to keep all the two vowels together, we have to consider these two vowels as one. So total number of words in that case will be, we have D, R, B, R. So we have four consonants with one vowel. So we have 4 plus 1. But it is 5 consonants. So it is 5 factorial. Okay, 5 words, 5 factorial. So therefore, total number of words will be 5 factorial divided by, we have 2 R here. Okay, so we have to divide by 2 factorial because we have 2 R. Then multiply with, we have 2 vowels. Okay, 2 vowels can be arranged in again 2 factorial ways. So this will get cancelled. So 5 factorial is equal to 120. Therefore, we can have 120 words in which all the vowels are always together. How many words can be formed by using the letters of the word painter such that all the vowels are never together? So for this, first you have to find the total number of arrangements. So here we have number of words, n is equal to 1, 2, 3, 4, 5, 6, 7. And we have no repetition here. Therefore, total number of words without any condition is 7 factorial. So 7 factorial. 7 into 6 into 5 into 4 into 3 into 2 into 1. That will be 5040. Okay, this is the total words. Now, we have to find how many words we have all the vowels together. So, to make vowels together, we have how many vowels? In painter, we have A, I, and E. So, we have to consider these 3 vowels as 1. Then the remaining, we have P, N, T, R. So 4 consonants plus 1 vowel, therefore 5. Therefore, total words in which vowels together will be 5 factorial into how many vowels we have. So in this bundle we have 3 vowels, so we have to multiply by 3 factorial. So 5 factorial is 120, 3 factorial is 6, so 120 into 6, 720 words in which vowels are together. But what we need is vowels are not together. So in order to find how many words the vowels are not together, we have to subtract. Total word is 5040. From this, how many words we have vowels together? 720. So that will be 5040 minus 720. So that will be 4320 words. In how many ways can a group of 5 men can be formed by selecting 3 boys out of 6 boys and 2 girls out of 5 girls? Okay, we have to select, okay, select 3 out of 6 and we have to select 2 girls out of 5 girls. So out of 6 boys, we have to select 3. So 6, 3, 3. Since you have to select both boys and girls, we have to AND. So whenever you have AND, you have to multiply 2 out of 5. So 5 options, you have to select only 2. So 5, 3, 2. So now 6 5 factorial divided by 2 factorial into 5 minus 2 is 3 factorial. We have 6 factorial is 720. So 720 divided by 3 factorial is 6. So 6 into 6. So this is the 20 into 5 factorial is 120 divided by 6 into 2. That is 12. So this is 10. So 20 into 10, 200 ways. How many different necklaces can be made using 6 distinct beads? So whenever it is to make a necklace or bracelet, okay, this is the problem of circular permutation. So circular permutation of n objects is given by n minus 1 factorial. Here n is number of beads, that is 6. Therefore, the required number of necklaces, okay, required number of necklace equal to 6 minus 1 factorial. That is 5 factorial. So that is 120 necklaces can be made. In how many 6-digit number can be formed using the digits 0 to 9? If the repetition is allowed, a number must be an even. Okay, so we have the given digits are, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A total 10 digits are there, but we have to take only 6-digit number, right? So 1, 2, 3, 4, 5, 6-digit number. Now, since the number must be a 6-digit number, in lakhs place, we cannot have 0. So other than 0, you can write any number. So they're out of 10. So you cannot write 0 in the first place. So the first place has 9 option. Okay. Now, since the repetition is allowed, okay, repetition is allowed is given. That means you can repeat whatever number you have written. You can write it again. So even write 0 also. So second place has a 10 option. Even third place, you can repeat the letter numbers. So third place also has 10 options, and hundreds place also has 10 options. Tens place also has 10 options. But since the number should be an even number, the last digit can be filled only by the even digits. So we have either 0, 2, 4, 6 and 8. So that means total 5 digits. Therefore, total number will be equal to 9 into 10 into 10 into 10 into 10 into 5. That is equal to 4,50,000. In how many ways can 5 men and 5 women be seated in a row if all men sit together and all women sit together? Okay. So we have 5 men. We can write it as a M1, M2, M3, M4, M5, and 5 women, W1, W2, W3, W4, W5. Now, seating arrangement means this is the question of permutation. Now, since all the men have to be together, okay, we can keep them as a bundle here. Okay. Again, all the women should be sitting together, so make them as one bundle here. So we have one set of men, one set of women. So we have total 2 sets, right? So 2 sets can be arranged. 2 sets can be arranged in 2 factorial ways. Now again, in this set of men, there are 5 men, 5 different men. So 5 different men can be arranged in 5 factorial ways. Again, in this set of women also, there are 5 different women. So 5 different women can be arranged in 5 factorial ways. So in total, we have 2 into 120 into 120 ways. So that will be 28,800 ways. A committee of 5 has to be formed from 6 men and 4 women. Okay, since it is a committee formation, it is a problem of combination here. In how many ways can this be done if the committee must include at least 2 women? Total we have 6 men and 4 women. We need to select only 5 people, and in this 5 people there should be at least 2 women should be there. Okay. Now at least 2 women implies either you can have 2 women, or you can have 3 women, or you can have 4 women. You cannot have 5 women because there is only 4 women maximum. Okay. Now, therefore, total combination will be equal to. Now, if we choose 2 women out of 4 women, so that will be 4C2. So, in order to make a 5 people to be selected, the remaining 3 people should be men. So, out of 6, we have to select 3 men. So, this is one possibility. Since we are using OR here, we have to add this. Okay. Now, how to choose 3 women? There are 4 women. Select 3 women. Then, the remaining men should be selected from 6 men. In 6C, to make it 5, you need 2 men. This is the second possibility. Since again we have OR, we have to add plus. Out of 4 women, okay, again we have 4 women. We have to choose 4 women into only 1 man out of 6 men. So 6 say 1. We have to simplify this. So that will be equal to 4 factorial divided by 2 factorial into 2 factorial, 6 factorial divided by 3 factorial into 3 factorial, plus 4 factorial divided by 1 factorial into 3 factorial, 6 factorial divided by 2 factorial into 4 factorial. Yeah, 4C4 is always 1 because combination of a selection of n, if there are n objects and you have to select all the n objects, so NCN is 1, and from n object if you have to select only one object, NC1 is n. So here 4C4 will be 1 and 6C1 will be 6. Upon simplification, so 4 factorial is 24 divided by 4. This is 6 into 6 factorial is 720 divided by 36. That is 20. Yes. Again 4 factorial by 3 factorial is 4 into 6 factorial divided by 2 factorial into 4 factorial. So that will be 15, and 1 into 6 will be 6. So 6 into 20, 120 plus 60 plus 66. So total is 186 ways of selection can be done. Okay. So these are the problems we covered under permutation and combination. We will again meet you on the